Number 4, here we go with steel wool and oxygen. This is one of my favorite demos to do and to have you guys think about it. And really, it almost pains me that we aren't able to do this one in class for the discussion that it starts to cause. Okay, so what you need to do is answer the first 3 questions. So looking at the observations for steel wool, and steel wool is what's actually in the container. So go ahead and make observations. Again, you're going for state of matter and color at the very least, and then you should be able to describe what this looks like a little bit more. In number 2, your observations are going to be looking around you. So for number 2, oxygen is the other substance we're going to use, and oxygen is in the air all around you. So you can write down again state of matter and color, because we'd seen earlier that their gases can have colors. We had that iodine gas in the very first one. So writing a color with your gas does make sense. Okay, so here we go. Oh, wait, we did the mom diagram first. Sorry, I'm really excited about this one. Okay, so I want you to do the mom diagrams, what you think steel wool and oxygen are going to look like. And you'll notice in the instructions, we actually tell you to consider steel wool to be a compound. And then do your one for oxygen. With these at this point, you think we've done enough of them and enough complicated ones that you should be pretty confident with doing this one. Again, you're thinking about state of matter, and do you have an element, a compound, or some sort of mixture? And we're telling you that steel wool is a compound. And then think about oxygen, and then draw it and pause the video and start the video up again. All right, here we go. Steel wool on the left, we have a compound, and it is a solid. So I've drawn my compound, and again, you notice I'm trying to make them look like they're touching. A common thing I see students do, and I don't quite understand it, is they will do this. They'll put them just ever so slightly apart from each other, that it's like, I don't know if they don't want them to touch. So this is not what we're going for. I know that they're really well organized, but I have this space between them, and I'm trying to figure out, well, is this a really dense gas or what's going on? But we actually want, and granted, maybe not every single particle will touch, but it needs to be clear that your goal is trying to get them to touch each other. So don't work really hard at making them close but not touch. Actually get them to touch. And then the oxygen is a gas, and it is an element. So I have one symbol for the oxygen, and I'm spacing them away from each other so that they have a space to go. And I will make a recommendation to you whenever you do mom diagrams, and oxygen is one of them, make it the circle, because it just makes life a lot easier later on. Oops. All right, here we go. Now we get to see what's going to happen. All right, so here we go. You're good whenever. All right, so here's what we're going to do. We're going to light it, and I want you to right away think about, okay, if I light something on fire, what are you going to expect to happen to the mass, and what are you going to expect to happen to the steel wool? All right, let's see if you're right. All right, now we're starting to see the mass start to change. And you might be like, what? I don't get it. And that's not a fluke. That is what is happening when this change is going on. You can see how, as that steel wool is burning, it looks very different than what you probably would expect burning to be. Usually people think about fireplaces and how they start with a piece of wood and then the wood is gone. Now we actually have an increase in the mass. All right, so here is the picture on the right is going to be for your after observations as well as for the mass. So you can look closely. I'll see, oops. See if I can bring that one back. Wrong way. You want to look closely in here at some color changes that are going on, and you might be able to see a texture change as well. All All right, so before I go on talking about it, I want you to answer the question that says, what caused the ending mass to be different than the starting mass? I want you to see if you can come up with something that would have caused that, and then that's going to help you draw your mom diagram. Because again, I've told you that the two things involved in this are steel wool and oxygen. So you want to think about what's going to possibly cause that mass to change, to increase, and then draw your mom diagram for it. All right, and then when you have your mom diagram drawn, start up the video again. All right, here we go. So what happened was we know the mass increased. All right, the only way mass is going to increase is if something is added to the original thing that we took the mass of. So we took the mass of the steel wool, but through this adding heat to it, it caused the oxygen to bond to the steel wool, and that is what changed the mass. So the way I've shown this is, again, in the center here, I still have all my steel wool, but then what I've done is on the outside, I've added oxygens. One, and I made sure I just added one to each one. And there's a couple steel wools in there that aren't changed because they aren't exposed to the oxygen. So not every particle of steel wool has changed. You could even see in that image, there was some blue, that was the new substance, and then some that just still looked like steel wool because it hadn't reacted yet. So this one, we have oxygen being bonded to it, so we have a new substance. It has a different color, and it has a different texture as well. So we have a new substance forming. All right, so go on to the last one. Again, same template as every time we do this question. Say what happened, say was it a physical or chemical change, and then give us some evidence to support that it is a physical or a chemical change. And then we'll move on to number 5, which is our last demo.